Not all lecture notes are important because most are copies of what I showed in class, and therefore you can see that when you watch my videos. However, there are a few that are important, and I will try to show those to you now. In other words, these were handouts to students, but they did not see that text during my lectures. This is a handout in which I said, build your own electric motor, have fun and earn extra credit. Okay, let's look which one. Circular motion of protons and electrons, that was all shown in lectures. Midterm evaluation. Okay, lecture 16. This one is very important. This is one of the most difficult lectures, lecture 16. And there are countless people in the world whose knowledge stopped with high school, who don't even believe what they saw. Because during lecture 16, I did a stunning demo which indicated that this voltmeter and this voltmeter, which are both attached to the same 2 points, show very different values, even reversed polarity. That demonstration, by the way, was first suggested by Romer in 1982, and he published that. And I did the demo already for the first time, I believe, in 1984, which was only 2 years after he published it. This is a summary. Oh, and now I'm testing you. Yeah, if you can answer this question, then you have a full understanding of Faraday's law, which most people don't. Okay, so that was lecture 16. Lecture 20, most physics college books have it wrong. Also a very important handout, which was largely written by my colleague, Professor John Belcher, and I adjusted it to my own lectures. This is perhaps the most important handout of my entire 802 lectures. I repeat, the credit goes to John Belcher. This part that comes now, very important. Okay, so that was the handout, Faraday's law. Let me take a look at driven LRC circuits. Oh no, that was shown in the lecture, so there's no need, I think, to show this to you. It was part of my lectures. I'll show it very quickly. Magnetic materials. Oh, I also showed that during lectures. So again, you can find that on my videos. Maxwell's equations. Well, of course that was on my lectures. But here you see them all four gloriously. Lecture notes, lecture 25, driven LRC circuits. Oh, I must have shown this in lectures. Probably was an overhead transparency. The second one is probably also, yeah, I must have shown this during my lectures. Oscillating sound cavities. Yeah, this was definitely shown during my lectures as an overhead. Traveling electromagnetic waves. Okay, yes, I remember that this was shown as an overhead. Ah, I already showed this to you. This was also an overhead. "15 questions about rainbows." Yeah, that was a famous overhead. Questions to you to test your knowledge about rainbows. "15 questions. I'll be surprised if you can answer 3 correctly. And then, yeah, this was an overhead. This was key because, remember, the rainbow is the result of the fact that when the angle of incidence on the drop is 60 degrees and the angle of refraction is about 40 degrees, that then the famous direction angle phi, in which direction you see it, is about 42 degrees. 138, if you subtract that from 180, you get 42 degrees. So that's why the radius of the rainbow is very close to 42 degrees, famous 42 degrees. Okay, I think that was it. So I've shown you the most important lecture notes of 802. Enjoy them!